Hello everyone, my name is Aidan Cox.
And my name is Scott Davis.
Today we would like to take some time to compare conventional tempered glass to thin flexible tempered glass. In this presentation we would like to highlight the processes that manufacturers go through to produce each type of glass. Additionally, we would like to analyze the advantages, disadvantages, and applications of the conventional and thin flexible glass. Overall, we would like to compare the two processes in terms of cost and assess the manufacturing readiness level of thin flexible tempered glass. So what is conventional tempered glass? Conventional tempered glass, also known as toughened glass, is significantly stronger than normal annealed glass. This strength arises from residual compressive stresses on the surface of the glass and residual tensile stresses in the middle of the glass. To produce conventional tempered glass, annealed glass must be cut down to the desired size. From here, the glass is checked for flaws and cleaned because the presence of imperfections or particles on the glass could cause issues during the next step of the process. Following these checks, the glass is fed through a furnace heated to temperatures above 600 degrees Celsius. After the heating process, the glass is quenched, causing the surface of the glass to cool down much faster than the center. It is the quenching process that ultimately induces the residual stresses in the glass, increasing its mechanical strength. A unique quality of tempered glass is that it breaks into small pebble-like particles rather than shards like annealed glass. There are several advantages of conventional tempered glass. The primary advantage of conventional tempered glass is that it is safer than annealed glass. It is not only stronger, but resists breakage. This resistance results in the glass dispersing into small pieces rather than shards, which could cause deep cuts and severe injuries. The increased strength associated with conventional tempered glass allows it to stand up to impacts, blows, strong winds, and other weather-related events, making it suitable for various applications. Conventional tempered glass is also scratch resistant. This means that the glass stays flawless and clear for a long time. Unlike regular glass, which breaks at high temperatures, tempered glass can withstand them. Although tempered glass has several great qualities, it comes with many disadvantages as well. The minimum thickness of conventional tempered glass is around 2.5 millimeters. Compared to thin, flexible glass, conventional tempered glass is much stiffer and lacks the ability to bend. Additionally, it is heavier and limited in terms of shapes that it can be produced. Unlike thin, flexible glass, conventional tempered glass experiences geometric distortions and waviness due to the manufacturing process. During the manufacturing process, the conventional tempered glass is transported on rollers, which could leave marks that interfere with the optical properties of the glass. A major drawback to conventional tempered glass is that it can no longer be cut and processed once it is tempered. Conventional tempered glass is suited for countless applications. Because of its ability to withstand impacts and weather-related events, conventional tempered glass is used for high-rise buildings, such as the Engineering Design Innovation Building located on West Campus of Penn State University. Within the Engineering Design Innovation Building, conventional tempered glass makes up many of the windows, doors, and office partitions. Conventional tempered glass is also used for shower enclosures because of its ability to withstand water at higher temperatures. Its strength makes it very suitable for sports applications as well, such as the glass walls in hockey rinks and basketball backboards. Now I'll pass the show over to Scott to talk about thin, flexible glass.
Thin, flexible tempered glass has a compressive residual stress at the surface similar to the stresses in conventional tempered glass. However, because thin glass is prone to clarity imperfections and poor thickness tolerances when processed with conventional methods, thin glass uses a fusion flow forming process and a molten salt tempering bath. Unlike the process for manufacturing float glass, the fusion flow process ensures that no machinery contacts the glass until it is sufficiently solidified. By having the molten glass overflow from two flat sides of the glass former before rejoining into a single stream, fusion flow results in a smooth and clear glass sheet. Fusion flow is capable of producing ultra-thin sheets down to 0.1 millimeters, but many thin tempered glasses are between 1 millimeter and 3 millimeters. The temper in these glasses is not achieved through a heat treatment, but instead through chemical strengthening in a molten salt bath. Within the salt bath, the sodium ions near the surface of the sheet are replaced with potassium ions. Potassium ions are slightly larger than sodium ions, and consequently, a compressive residual stress forms on the sheet's surface. The process of chemically strengthening is relatively lengthy and involves preheating the glass before submerging it in the molten salt bath for between 3 and 24 hours. Thin tempered glass may be selected over conventional glass when low weight, flexibility, and increased strength are required. Certain chemically tempered glasses can be as much as 4 times greater in strength than heat-tempered glass. Because they possess a degree of flexibility, thin tempered glasses can withstand greater impacts. Their flexibility allows for multiple cycles of bending without fracturing. As a result of the fusion flow sheet former, optical clarity and surface smoothness exceed that of most conventional glasses. Finally, thin flexible tempered glass does not self-explode like conventional tempered glass. Unfortunately, the production of thin tempered glass is mainly limited by the size of the salt bath furnace. Glass sheets or individual parts must be processed in batches, reducing the efficiency of manufacture. The increased time between batches and requirement for specialized furnaces make thin tempered glass a more costly solution. Additionally, the fatigue life data for thin tempered glass is difficult to predict because little data has been gathered on its performance. The applications for thin flexible tempered glass are commonly seen in the screens of consumer electronics. Gorilla Glass, a product of Corning, is a popular tempered glass used for cell phones. Before cell phones, however, Corning was focused on the use of flexible tempered glass for automotive windows. These glass products could flex or hinge and allow for easy removal in convertibles. Today, thin flexible tempered glass is used in many of the same applications where conventional heat tempered glass was originally used. For instance, curved glass panels can now be made with thin flexible glass as opposed to forming glass before heat tempering it. To compare the manufacturing cost of conventional tempered glass with those for thin flexible glass, we can analyze the differences in machinery and production time. For the comparison of any two processes, similar or not, it is rarely possible to find exact dollar amounts because the processes do not scale equally. Instead, we can base our analysis on the degree of development and complexity of a process. Thin tempered glass requires a fusion flow sheet forming process, which is unique to the production of thin glass and requires more precise control than float glass. The salt bath furnaces used for chemical tempering are also restricted to relatively small scales as opposed to the large tempering furnaces currently in production. Lastly, chemical tempering is a lengthier process than heat tempering, and when combined with small batch sizes, production efficiency is decreased with labor costs remaining elevated. Manufacturing readiness levels are a set of criteria used to assess the readiness of a product or system for full-scale production. Our team decided to give thin flexible glass a manufacturing readiness level of 9 because it is mass-produced by several companies for their products, such as Corning and Samsung. We believe that thin flexible glass does not deserve a manufacturing readiness level of 10 because the process has not been optimized for scaling productions to a company's individual needs.
In terms of the references that we used to produce this presentation, we primarily tried to gather information from unbiased sources, such as journal articles and technical presentations, because they were more informational rather than persuasive. In order to understand the processes of the conventional and advanced manufacturing methods, we used several manufacturers' websites that were strictly discussing how the glass is produced. However, when it came to analyzing the advantages and disadvantages of each type of glass, we referred to many company websites and blogs, which we found to be extremely biased. Many of those websites favored thin flexible glass. However, today, we cut through the hype of it. Thank you for watching.